Well, welcome to the NSGIC 3DEP for the Nation interest group meeting. It's been a while, so we're glad you all could join us. Today, we're going to have a USGS update without USGS, so any of the USGS folks on the line can jump in, correct me. But primarily, we're going to talk about some work Phil has been doing, developing a community FAQ for 3DEP data distribution services and applications. He's put a lot of work into this, and we're hoping that it'll be a valuable resource as well as a living resource. And then we're going to talk a little bit about where we are with 3DEP as we close out for the project, as we start to look at closing out for the project. Thanks to Brian Hadley for providing this latest status map. BAA, they received 26 proposals in 16 states and approved 23 proposals in 14 states, or approximately 180,000 square miles. You see those nice bright green spots filling in all those, well, not all the holes, but a lot of the holes. The estimated coverage at the end of FY22 was 89.5. That's either covered or in progress. So that's a great number to see. And this status map, you can go, it's updated regularly. So if you're ever curious, you can go get this map from the USGS 3D Elevation Program website. Any other USGS folks want to contribute anything? Have great news or exciting thoughts? Or just something to add? It doesn't have to be exciting.
Well, 89.5% is pretty impressive.
Very impressive, yep. All right, then with that, I'm going to turn it over to Phil Worrell. Jason, you see we credited your image here. This is the image that launched 1,000 ships. Phil, do you want to, Phil, you can talk about attending the meeting last June and how
Okay.
how the slides spoke to you.
Okay. Can you go ahead and stop sharing?
I can.
Okay. I'll share mine. It's just going to look like the exact same slide.
Oh, that'll work out well. That'll look like we coordinated or something.
That's right. Okay, participants can now see my screen, it says. Okay. All right. Well, thank you, Linda. Yeah, the pyramid that launched 1,000 ships. A little background, well, you already know, 89.5%, almost 90 coverage. Either completed in progress or contracted for. And I don't know the exact percent of what's currently available, but the map there on the right shows the US IEI layer in C-Sketch as of November 2022. And you can see, obviously, Alaska and the continental United States getting to be very green as well. So yeah, it's not the same percentage because there's the lag with the contract work, but the links there in C-Sketch and that's updated regularly by USGS. So feel free to use that link when you get the slides later to keep track. But the point, I guess, is that we have a lot of 3DEP data available to us. But our challenge is really how to efficiently get to it and to use it. And that's what today's discussion is. And this really goes back to a presentation that Jason and Rick Brown and Rob Dollison gave us back in June to this interest group. And they presented this pyramid. Which was pretty simple and elegant in its first look, but once I started taking a deeper dive into it after the presentation, I realized there was a lot to unpack there. It's showing data both available in raster and point cloud formats. Plus, it's not just showing the data. It's showing the tools and applications that are available for both the expert and the DIY kind of user and the casual users. So like I said, there's a lot to unpack. And when I started unpacking this, I came up with, in this pyramid that represented 11 standard 3-depth data products, 16 derivative data products, and over 25 applications. And so that's a lot from just one little slide. And really it's an opportunity, and that's what I saw this presentation as back in June, was really as an opportunity to try to figure out how states, how we can leverage these resources, and how we can make existing and new ways to get this 3-depth data into the hands of our end users. And in addition to like the traditional data download capabilities and hard drives and all that stuff that we're used to, we really see in this pyramid a transition away from those download first type paradigms, and the focus on standardizing data management and provisioning. And not only does this pyramid include web services, but also emerging open source and cloud native geospatial solutions. So I wanted to make sure that we had, take a look at those and see how they might fit into our enterprise GIS. And at the end of the day, it's in our best interest, to follow and embrace NSGIC's, build once, use a bunch model. But to do that, we really need to understand what, when, where, and how these existing resources can be used. So the question is, how do we do this? And there was a lot of different ways I thought of how to divvy this up. But the idea I came up with was really producing a series. You put a template together and create a series of frequently asked question documents for each one of these resources. And what you're seeing today is draft one of that. And these are all available, going to be available for you on our NSGIC Google Drive, where you can view them, comment on them, download them, and hopefully figure out how you can take advantage of some of these existing resources in your state's enterprise GIS environment, as you guys see fit. And all we ask is that you share your experiences and feedback with us. And these are draft one documents. So I'm really hoping you guys are going to, give me some timeless prose and some good contributions to these documents that you access, and that way they become a living resource as we go through the next years, using and leveraging our 3-depth data. Yeah. And hopefully this will also be good input back to our federal partners, USGS and NOAA and the others who are doing some really cool things out there, as illustrated on this pyramid. I'm not want to speak for our federal partners, but if you find a particular application or data set does 95% of what you need, and it's just missing a little bit here or there, I think this is a great forum to provide that comment and feedback to our federal partners. And they may see a way to get to that last 5% for you and serve the community without you having to go out and reinvent the wheel or do something on your own. So that's kind of the philosophy behind this. So again, each one of these documents, as of writing this report, documents one of these resources. Again, there's 11 standard data products, the way I count them, 16 different derivative products, and over 25 existing tools or data access methods. And that's what we're gonna dive into. I have two main documents. I have this introduction document that I'm gonna go through in some detail, but then I also have a matrix. The matrix is the graphic there at the bottom where I've put these all together. And I'm just gonna flip over to that actually first, just to show you that. Now, this is still a work in progress. I don't have any of the fancy hyperlinks in here yet. I will by next week. But this is the listing of all those standard data products, all those derivative data products, and all those applications, tools and methods to access this data. And they're all listed here. And these are all the links, the URLs to the actual resource at USGS or wherever it might be. What I'm going to be adding is over in this FAQ column, I'm going to be adding a link to that Google Doc that I've created. But this is a real easy way to, the matrix is to see everything. The other thing it does is the data products are listed across the top. And if you hover over them, I'm going to get a pop-up tool working here. You can actually see what the name of the product is. In this case, this is a LiDAR DTM cog tiles on Microsoft Planetary Computer. And then along the left are the different apps that use those resources. And so these are all the apps that are documented. And the ones with the green, by the way, are ones for, I think, serious consideration by the states. And I've done a preliminary cut of what I think might be real interesting tools or data sets for folks to use. Totally open to you guys' suggestions as what might be green or what might not be green going forward. But just trying to provide a little bit of focus, since we have so many different data sources and so many different tools, trying to give a little focus to states on what might be the low-hanging fruit of what to look at. And then where all those things intersect, that's where the colored cells are in between in the matrix. So you can see with a particular application what data sets it uses, and conversely with a particular data set, what applications are using it. So you can get an idea if you're, how to find the best of breed from both by simply looking at the intersection. That's all I'm going to talk about for that right now. I'm going to go back to the actual document, and this is the introduction document that I've prepared. It's about 7 pages long. And a lot of the stuff I'm talking about here right now today is in the introduction. We've seen these graphics already. What I wanted to point out was the kind of the lists and how they work. There's 3 lists: standard, derivative, and then applications. This is the standard data products, and you can see the 11 products listed under the USGS National Map Downloader and other tools. The way it works basically is I've identified, given each product a name, and then the link text that's right behind it has the link to the actual site where that resource can be accessed. And then the FAQ link behind it, that has the link to the FAQ document that I wrote about it. So it's pretty simple in format. And what I also have in here besides the list is then those green items we saw on the matrix, the considerations. I have actually a paragraph or 2 written about each one of those. So you get an understanding of why a particular data product or an application was highlighted in green on the matrix. And so there's a little bit of narrative there. If folks want to write more about these other ones, I am all in on allowing you guys to edit this and contribute to it. So then the next section is in the introduction is the derivative data products. We'll be going through a few of those in a bit. And then the last section of the introduction is that list of the 25 plus tools that are available today to manipulate those and work with those data. So we're going to just basically be stepping through some of these, and I'm open to questions as we go, or we can wait to the end, whatever you guys feel would be beneficial. So let's start with number 1 on the list, and it's the first one recommended, by the way. It's the 1 meter project-based DEM. That's kind of the gold standard for 3-depth. That's the highest resolution and most detailed product, DEM product that's being produced. And just to go to the document here, I'll just show you what we've got. So. Taking a little bit of time to refresh. Murphy's Law. There we go. Come on. There we go. All right. Right now, these are Microsoft Word format. I am going to be converting them to Google Docs, but that'll be seamless. You won't see the difference. I was talking to Linda, and I think converting all these into Google Docs will give us a little bit more flexibility with folks adding comments and contributing to them. So I'll be doing that in the next couple of days. But you can add comments to the Google Doc or the Word doc. It does not matter. It works pretty much the same. So what we have basically is the template identifies. There's a picture of what the data resource is, and in this case, it's the project-based 1 meter DEM tiles. They are seamless within the collected project area. They're not seamless nationwide, as you guys are aware, and that's a 1 meter pixel product. Eventually will be nationwide. And here's an example. So there's a link to that. There's also then a typical example of what, say, the download capability looks like. And this is on the national map downloader tool of how you get to that data and how you find it. So the example there. More importantly, are those that follow that are the sources. This one's kind of unique in that there is multiple sources that you can get to the 1 meter DEM tile. You can get it directly from the National Map Downloader, as I just mentioned. But then there's also the availability of web accessible folders. HTTPS at Rocky Web is a way to get to the data. And you can also get it directly from Amazon Web Service by browsing there and at data.gov. And these all are complete maintained collections of the data. I am not sure if one of these is more authoritative than the other. I'd be very interested to hear from USGS on that. If, for example, we should be recommending one or the other, or this may be just up to personal preferences, what you're comfortable with working in what environment. So after the list of sources, there is the what is it section, which basically describes what that resource is. And then after that, we have a few more details, such as what is the format of the data. And you'll notice a lot of the raster data now is available as cloud optimized GeoTIFF format. I don't know the exact numbers, but I believe USGS has gone through, and for all the 3-depth data, it is now available in cloud optimized GeoTIFF file format. Now that cloud optimized GeoTIFF is still a standard GeoTIFF, so it won't make any difference to you as an end user whether it's COG or not. But if you are interested in accessing it through the cloud, then that COG format really is what you need. So it's there. Vertical accuracy obviously depends on the quality level of the LiDAR data that was used to generate it. So this is just right out of the base specification, but tried to bring a few things together so you don't have to go looking to get some basic questions answered, like what's the vertical accuracy, what's the coordinate reference system, what's the vertical datum, and also a link to the metadata. How you can use it. This is where I really need your help. Now, obviously, the 1 meter DEM has got probably the most longest list of uses. I did not list any of them in here now, but this yellow section here is in every one of the FAQs. And what I'm asking for in yellow is I'm asking for your help. So, I'm asking you guys to input, applications that use this data, and especially, those applications that were identified, the business uses cases and the mission critical activities that you guys identified in your states in the 3D Nation study for your state. This is where I'd really like to connect those dots and to have you guys put in some examples of how this particular data set is satisfying your business uses or your mission critical activities that you identified in your 3D Nation study submittal to the USGS. Next section is ease of use rating. Now, this is a really highly subjective rating. And at this point, I've just made my first best guess at a rating of 1 to 10, 1 being casual or basic, and 10 being expert or advanced on what the user skill needs to be, what the functionality of that data set is, what's ease of use, and then an average score computed for it. So you can kind of get a feel for where this particular data set or where this application fits in that DIY to casual user pyramid scheme. So definitely interested in your input on those as well. What else do I need to know? This section typically is, gives some additional narratives about it. And an important thing to notice is that, again, I mentioned earlier, the 1 meter DEM is only seamless within the project area. If you're looking for a nationally seamless DEM product, you really need to be looking at the USGS 1/3 arc second or 1 arc second or 2 arc second seamless DEMs. These were previously the NED, the National Elevation Data Sets, that were maintained from about 2000 to 2014. But after 3DEP, they got integrated into the program, the 3DEP program. The NED name got dropped, though people still will refer to them as the NED, but they are the basic same product. But what's important to note is that they are updated on a regular basis. I believe the 1/3 arc second, if we go to that FAQ sheet, you'll see that it's updated quarterly by the latest 1 meter DEMs. So it's not a nationally seamless 1 meter DEM, but it is a nationally seamless DEM of the best available data. So where there is 1 meter 3DEP data, that will be available in that DEM. So especially if you're looking for something statewide or a multi-state or regional area, that's probably a pretty good data set for you to be looking at, maybe versus using the 1 meter DEM, because you have USGS do all the heavy lifting for you of making it a seamless product. So, and that's all explained in each one of the FAQs. Last but not least in here is, this is where I really need you guys, states and user experience. Just, put in whatever information you feel is beneficial to understanding the use of a data set or the use of an application, or any comments about improvements or et cetera. This is kind of where the bucket, the catch-all for us to collect information and collaborate with amongst each others to get a better understanding of a data source or a better understanding of an application. So that's the basic template. And I went through this one a little bit slowly just so we could see the pieces and how it fits in. This is also a very important data set, the 1 meter DEM. So this is the go-to in many cases for folks. But every one of these is laid out that way. Just that simple. Let's see. The other one I wanted to point out in this, I don't want to point out any ones. We're moving on. Does anyone have any question about the standard data products at this point, or how these FAQ templates are laid out before I proceed? Okay, moving on. Derivative data products. 16 different derivative products to my count. This was pretty impressive. For example, the net contour tiles that are generated from the 1/3 arc second. These are available from the USGS. This is also the contour layer that appears on the national map. Is a source that is updated again every 3 months, and so we have a much more dynamic capability to see this new 3-depth data coming in. Probably one of the biggies is this dynamic elevation service, web coverage service, that is developed and maintained by USGS. I'm calling this a derivative product because it really is. As a coverage service, it provides a whole bunch of visualizations off the shelf by simply ingesting it into your GIS software. And I don't know how many folks are already using this coverage service. I'd be interested in hearing that, but there's a myriad of different visualizations of the data from this image server. We have a description of it. We have hill shade, multi-directional, elevation tinted, slopes, aspects, contours. It's a format as Esri image server, and it has a stated vertical accuracy, which I think is slightly different than the source data. So that's important to note that in some cases, the metadata or the accuracy of the product is a little bit different. But you get the idea. And for more information on those, I have links here where you can do it. Again, following the same format. But this, I think, is the advantage of this, obviously, using a coverage service into your enterprise GIS is you don't have to deal with the downloading or the storing of these data, nor do you have to worry about the development and the storage of these derivative products, because they are on the fly coming from the image server. So that makes sense. I think one of the more interesting ones that I came across when I was going through this was I knew Amazon was doing a bunch of work with putting all the LiDAR point cloud data and the DEM data available on the cloud, working with USGS. What I did not know or realize was how much Microsoft and Microsoft Planetary Computer was doing in the Azure cloud to make these products available. And they have, besides the base product, they have 9 different derivative products that they have produced and made available on Microsoft's Planetary Computer. And I just wanted to show those to you here. So here's the link to Microsoft Planetary Computer. By the way, Microsoft Planetary Computer is both a data source and an application. So I have 2 FAQs for it. This particular FAQ is focusing on the data. The other FAQ outlines how to use the Microsoft Planetary Computer to do geospatial processing against that data. And so there's 2 FAQs in that case. But each one of the data sources is shown here with a brief description. And these came right out of off the site. So I will make a point to keep these updated as they bring in more products, or as they change the documentation and anything. But the direct link to the data is provided here, so you can get to it. But they've generated things like height above ground, the point source information of where the actual LiDAR point cloud data is coming from, LiDAR return classified data. We have a DTM, and we also have the LiDAR raw classification and native. I'm not sure what some of these applications for some of these are, but I've just documented everything that they have made available. So those resources are available. Any questions on the data sources so far? Okay. I encourage you to go through and look at them and get a feel for which ones might be appropriate. Again, many of these are available for download or for direct visualization. And that's where the next section of the tools come in. Is how do you get to these data? What are the different ways? And as that matrix shows, there are numerous ways to get to a particular data source that you may be interested in. So I definitely suggest you go back and look at that matrix and see, if you're interested in a particular data source, see all the existing ways that you can get to it, and then explore those and to see how they might fit into your workflow for your enterprise. I listed the most simplest one here, and this was actually quite amazing. I had never used this. It's fairly new. It is the USGS National Geospatial Program On-Demand Topo Builder. And what this does is this allows you to build an on-demand quad map of your area of interest. You can build it based on a standard quad map location, or you can pick your location of where you want the quad map to show up. In this case, I centered it on my house, and I got a PDF within about 20 minutes. I got a PDF quad map centered on my home, which I thought was pretty cool. It's a very professional looking map. It uses the 1/3 arc second contours that are generated from 3dep. And so you have, on a quarterly basis, an update of the contour data. So it's a fairly dynamic product, and it provides a format that many people are familiar with, is the standard USGS 7.5 minute quad format. The neat thing is it's centered on your house or wherever you want it centered, and you can generate it on demand. But I thought that was a very interesting and simple approach to getting to this data. And I rated it 1 across the base because it's for the casual user, it's basic, it's easy to use, and if someone's looking for a simple map that they would be comfortable with printing or sharing, you can't beat a standard 7.5 minute quad map for that type of application. So again, I'd never used that before, but I saw it as a resource and checked it out, and I was actually very impressed. It's definitely something that you could easily integrate into your hubs, your state hubs, or your platforms without too much problem. In the recommendations, by the way, let me go here. For these, I have 2 sets of recommendations that I came up with. These open source and nationwide coverage applications, and then another group called restricted access or limited coverage applications. And the difference there being that these are more of the national USGS free things, and some of these in this access or limited coverage require that you have some kind of licensing or software to use it. For example, the open topography is freely available for academic use, but not necessarily for commercial use. The USGS and NOAA Coastal Elevation Database, CONED, is available, but it's only in the coastal regions. So it's not a national-wide service. But if you're on the coast, it's definitely the go-to for integrated bathymetric and topographic LiDAR data products. Microsoft Planetary Computer and Google Earth Engine, again, are commercial products that provide a lot of open data and free services, but they're not necessarily totally free, depending on what your applications are. So it takes a little bit of research to do that. So I made two buckets in this set of considerations, because some of the products were open and widely available, and some not as much, but still definitely worth mention and worth researching. So I hope you guys look through these. I was going to click on the advanced viewer. Oh, I'm sorry, I'm gonna skip that. Let's go LiDAR Explorer. So what the USGS LiDAR Explorer lets you do is very simply just focus on the LiDAR data, the 3D data. You can get similar type access to some of these data products through the national map, but what you're getting here is you're getting access to some of the cloud optimized formats that available in Entwine and cloud optimized point cloud format. So that really kind of opens up the possibilities to do some more interesting and more modern things with the data without having to download it. So that's why I encourage you looking at, the LiDAR Explorer as a resource for learning how to gain access to this data, because it does change the paradigm on how you use it. And I just wanted to show you real quickly. I have it opened here somewhere. Maybe I don't have it open. Open. So if you were interested in that topobathy LiDAR, that LiDAR we were talking about earlier, you can see very limited access to that data right now through this resource. But if you happen to be in that area, and you need that data, it's available. Where LiDAR, topographic LiDAR is available, obviously much more detail. I'm going to zoom into Indiana just because that's where I live, and just show you how easy it is to select a piece of data and find out what's available. So I'll define the area of interest here. That's 11.4 square mile area. And Indiana Central, Hamilton County, 2017 is the latest. You can see we have some previous, this is QL3 LiDAR, happen to know that, but in 2012 was the first collection. So we have the 2017 collection. Now what's really cool is this little green button here allows me to dynamically visualize the LiDAR, either the Entwine data in the Poetry viewer or the cloud optimized point cloud in that viewer. I'm going to go ahead and open up the Poetry viewer to view the data. We're in Hamilton County, I believe. We'll let that fire up. Take it a second. Hamilton County is about 400 square miles. What you're seeing here is the 400 square mile county, that data set coming in from the Entwine LiDAR point file cloud tiles. This is not a mosaic data set. This is a on-the-fly dynamic data set that's being generated from the endpoint point tiles. And as we zoom in, we are going to see a greater resolution and more pixels from the LiDAR data. I apologize for the semi-slowness of it, but I'm dealing with a huge data set, as you can imagine, in there. We can also, oh, log me out. Can't believe it did that. I'd save this one from the cloud optimized point cloud. It's going to make a liar out of me. Same area, just using the COP-C viewer. But again, the idea is the data is streaming directly from the source on in the cloud, and there's no download required. And it doesn't look like it's going to behave right now. Neither of them are behaving. Of course they're not. Okay, moving on. Another interesting resource, and I've heard a number of folks have mentioned what they'd like to do would be have an API to not just say use the resource, but to have access through a programmatic access through an API. And I was not aware of this until I started researching it, but the national map has an API that can be used to basically customize access to the data. So you can use it to customize access to products, to data sets. You can use it to access or to set up notifications about what's going on with the map service. And also you can use the services that are available to visualize the products, and you can customize those through the API. So you can have access to the national map data without having with your own user interface, if you will, your own wrapper around it. So if you have a particular tool that you want to integrate into your state hub or portal, you as opposed to just simply opening up the national map viewer and saying, good luck, folks, find my state in the data, you can basically give them a custom look into that data through the API. And I think that's something well worth investigating, because USGS is investing quite a bit of resources in maintaining the national map as the primary source for many of these data. It's not just 3DEP data, it's all the data. So I'd strongly encourage you looking at that. So again, that's the end of the introduction section. I've briefly introduced you to the matrix, and I've hit on a few things. What I really wanted to do was just make you guys aware of these resources that are now available, and really start a dialogue and start looking at how we can use them. But I also wanted to point out, and Jason just presented on this yesterday, and he presented on this a couple months ago as well to the 3DEP and 3D HP interest group, that USGS is by no means done with what they're doing with making this data accessible and usable. And Jason's on the phone. I should have him describe this. We were inviting Jason to present on this later in maybe a couple months, but USGS is looking at providing a more holistic program for accessing these data. And I think this is really where states may have an opportunity to participate in this environment. And the concept is of a data mesh that is made up of many data lakes. And the data lakes can be different sources and resources, whether they're federal agencies or NGOs or maybe even states. This may be a smart way for state and federal collaboration with these large data sets that we're dealing with, and especially with the derivative products and that folks are producing. So this by no means is the end of the story. It's literally that pyramid is really the tip of the iceberg as to how we're going to evolve over time in access to this 3D data and into other data sets, 3D HP, etc. So it's really exciting to see the collaboration and the work going on at the federal level for making all these different data streams and applications available. And I think states are going to, and are good position to leverage those. So with that, I am open to any questions or discussions that we might want to have about this and next steps.
Well, this is Linda. Phil's obviously done a lot of work here, and we hope it's both useful, but also a means for you to share your insights. And Jason, you're, volunteering to kind of take a look at things. We want to make sure we have the information right. And, USGS input, state input, vendor input, all of that. But the main idea is to create a community workspace for leveraging the work that you're all doing in the 3D data applications and, your experiences and your observation. I know it's going to take a while to absorb. I appreciate that, Steve, but I guess I go back to my question. What are your questions or thoughts on how this resource can be used and developed? Understanding you'll need some time to digest all the work that's been done here.
Hi, Linda. This is Steve from Vermont. I have just a thought or comment question, however you want to take it. I'm curious because we host a lot of products, LiDAR-related derivative products through our portal. It seems as though all of these products stem from this underlying like DEM, which is the very popular kind of primary product. And it would save a lot of overhead in terms of space for servers to host these derivative products if there was an opportunity to just generate them on the fly for a specific project area. A lot of times we have people that are, and I'm one of them, it's inevitably somehow my area of interest is on a seam line or in between maps. So it's difficult for people to download data when we're chunking it up into portions, and their area of interest happens to be on a seam line. And oftentimes the seam lines is where distortions take place. So this is just fascinating to have a resource where you can have data and you can select your area of interest, no matter where it might be, and then generate these products on the fly. Yeah, it's kind of blowing my mind.
Yeah. So one of the tools, I didn't demo it, but one of the tools that I came across that solves that problem very, very nicely is Grid. And let me, I will find it and open it up and show you. It is very similar to the open topography, except that it is it's a government site, and it is the National Geospatial Agency's. It's called the Geospatial Repository and Data Management. I'll get back to sharing. I'm sorry, you guys aren't seeing this.
I'll stop.
Okay, sorry. Okay.
And Phil, you're going to put the link in the chat as well, correct?
Yeah, yes, I am. I
Okay.
didn't want to put the link in while I was
They'd all
presenting.
rush over there and be distracted. I know.
I know they don't start editing my document. Okay. Okay, you seeing this? You see my screen?
Yes.
Okay. So NGA's geospatial repository and data management grid is a really cool tool, and you can get a free login. It's a little bit painful to get the login, but you can get it. And as a citizen, you don't have to be in public safety or defense or anything. But what it allows you to do is identify that area of interest that you're in, and then select the different data products that you want to extract from it. And it has quite a lengthy list of derivative products that it generates on the fly. Yeah. Let's see, I'm trying to read. I had a list in here of the different products. I thought I had a list anyway. But you can get different generated products on the fly and then download, and it gives you a notification when the data is available for download. Now, it's not a visualization tool, it is a download tool. If you're looking at visualizing and on the fly, derivative products, I think the web coverage service that USGS publishes would be a great tool to use in that environment. If you're an Esri shop, Esri's Living Atlas, which is also documented as one of the data sources in here, Esri's Living Atlas is updated on a regular basis from the best available 1 meter DEMs from USGS, and they proactively update that. So if you're an Esri shop, you can consume the elevation services available through Living Atlas right into your enterprise Esri environment.
Okay, be careful in there. Somebody left a big old wad of toilet paper in the toilet. It need to be plunged.
That wasn't me.
I know that wasn't you. We'll see who's.
I don't know that we want to know. I hate when that happens.
I do too. All right. Did you want to get back? Are you still working on stuff, or?
I think I answered the question.
Yeah. Any other questions for Phil?
While I'm thinking of it, I'm going to copy this link right now. I'm going to go to chat, and I'm going to paste it into the chat. That is a link to this introduction document, which has a link to all the FAQ documents. And I really encourage everybody to read it. I know this is somewhat like a drink from a fire hose. But I was just very impressed when when I started looking at all these resources that Jason and Rob had talked about back in June. I had not realized how many of these were available as services or made the data available in cloud optimized formats. And I think that's really opening up our options as states to take advantage of these data sets without having to make and pay for our own data repositories, without having to develop applications or tools that are can provide basic services to view the data or to download it. I think a lot of these things can be leveraged with a little bit of creativity on state's part and integrated into existing hubs or or enterprise GIS systems you guys already have. Obviously I've focused on LiDAR data and the DEMs and the derivative products, but at the same time, these tools provide access to other data sets as well that might be of interest to you. So. Has anyone used planetary computer sources in ArcGIS? The question from Nate. I have not. I am by no means an expert on that. So, but anybody?
I'm on mute. Thank you. Jim's comments. Do we want comments? Yes. The idea, Jim, is that this is a community workspace. While we can't have everybody in there editing the document, we want people to add comments, insights. If you've had an experience with something, we want that in here. If you think the document, if you want to reformat it or something, that's up to Phil to decide, but we really want your experiences, insights, and observations. So that's the whole purpose of this thing is to start collecting. Yeah, Phil really did a ton of work to get this thing going and get it to start it, but we're looking for a community of information. It's not, it's not just what Phil thinks about this. We want to know what everybody's thinking about, especially people that have actually had been able to touch these tools and play with them and try to apply them. We will follow up this presentation. I'll send an a message out to the group with a link to the document. We'll send a link to the recording and the presentation as well, so folks can get the background on that. Any other questions or comments for Phil before we do one more, just close out one more activity?
Yeah. Hi, this is Steve from Vermont. Just another quick question regarding the data pipeline. It seems like there's a lot of options for data delivery, and it seems like it lends itself to forked data sets where when a change takes place, that change might not be reflected in all of the data sets. But I understand this to be something that is through 3DEP. All these options for accessing the data are going to one, almost like a REST endpoint of the data. There's only one data source. Is that kind of how it's designed?
The USGS resources, yes, absolutely. They go to the authoritative endpoint of the data that USGS publishes. And Jason might be able to speak to this, but I know folks like Microsoft, Esri, Google, Amazon are all striving to keep their copies where they have a copy of the data. They are striving to keep it as current as possible, and at least are being informed or have some mechanism to know when the authoritative data source is updated, so that they can then go update their derivative products or services that they have built off of those. There might be some lag in there, but it's pretty impressive what I've seen as far as the time between publishing and these data then appearing in these different resources.
All right, then. Thank you, Phil. So appreciate the work you've done, and I know this is going to be an ongoing effort to incorporate other people's information. So thank you very much. I just wanted to give, oh, that's a bad image. Sorry about that. I just wanted to give a brief update. Most of you know that this project ends May 14th in 2023. And that is 5 years. I can't believe we've been doing this for 5 years. And we have made an inquiry to USGS to see if they would like to establish a new cooperative agreement. And so far things feel good, but there's certainly no commitment on their part to do so. But I did want you to know we are hoping to continue the work. But I also want to let you know that, all of these resources, the things that we've been working on, they're all available at the 3DEP Info Hub. Let me get that in the chat for you. Phil's going to add, can't get things. Phil's going to add a link to this FAQ resource and we also have in there, some of you may not have seen it. We've also have a checklist for maintaining your 3DEP momentum that was generated at the NSGIC annual meeting this year at the workshop. And it's a checklist for you to download and maybe spur some ideas on what you could do in short term and near term, short term and long term to keep your 3DEP momentum. A lot of great ideas in there that states contributed as far as what they were going to try to achieve before the end of the project, as well as things they were going to, that we'd need to address post-project. We've got the planning guide, the planning app, best practices, all of these things are in there. So please utilize this resource. This is where we, this is the keep. This is the keep for the whole project. So as we move towards closing out the project, we just wanted to make sure folks were aware. Any questions about the hub or the resources? All right, well, with that, just a brief reminder that our next related event would be the 3DHP forum that'll be in January of next year. We will not be having a forum this month because of the holidays. We'll not be having a 3DEP state team meeting because of the holidays. So you get a little break from listening to us talk for a while. And we just want to appreciate your participation today and look forward to seeing how folks interact with this document and how it grows and evolves. Phil, did you have anything else?
No, I'm good. Yep. Just feel free to open up those documents and start putting comments in there, trying some of these things out yourself. I think it's the idea was to kind of give them into a more consumable format that you could look at easily and quickly without having to do a bunch of research. So hopefully it will get you a good leg up on starting to explore these different resources that are available.
And Phil, just one quick comment. Should they wait until you convert these to Google Docs?
No.
You think the comments are going to translate just fine?
Yep, I'll make sure they do.
Okay, great. Well,
Yep.
Thank you, everyone. Appreciate your input, Phil. Thank you for all your work. And we'll talk to you guys next month.
Thank you, Phil.
Thanks. Bye.
Happy holidays. Thank you.
Yes, happy holidays.
Thank you.